Hello guys, after very long break on my channel, it's caused because I don't have time. I spent my whole time on school and I didn't have time for making videos on my channel. But today I think we can find some addresses to present hook and reset hook with game over renderer to Steam.
Here is the list of we are going to do in order.
And we can get uh, these two files from Steam directory. Just find Steam, open Steam location, Steam, and we have this here. 32 bits, 16 4 bits, and our lock. Our lock it will help us with finding hook, and this is it. Create device hook. This is a function which creating device hook, like a name pointing at this. So yes, we can open our files with Idea Pro. Open 32 bits with default settings, and we can also open 64 bits, but of course with 16 bits version IDA. This is it. Also with different settings. No. First, what we can do is change the view to text view. Use plugin function string. I don't know how to say that, but okay. We have 414 strings generated. We can open view strings, and now we can search something like hook functions. So hooking, and we have something like failed hooking. So many functions. Okay. And this we can decompile this. To decompile our program, we have to use plugin hexrace decompiler. And okay. So we have here load library function. Load library function is getting from process address 27. This is kernel 32.dll module. So this is getting from kernel 32 module. This seems to be bug function because we have first argument our hack function, our hooked hack function, and our original hook function. So yeah, this is 400% this. We can also check this, and this should be hooked load library A. Move A or error. Yeah, this is it. So yeah, this is our hack function. We have hack free library, load library, external A, load library y, a, load library dll. Also, okay, so yes, this is hook function, name it hook function. Okay, and now we can use our finded string device hook code. Find it, and this is this function, decompile it. And what we have here we have one function that takes 3 arguments, 1, 3. Here we have function which takes 3 arguments, and this is log function. We can see this message and type behavior flags. When we look here, we have the same message, type, and behavior flags. Yes. So this is it. We have 2 more functions. One takes 1, 2, 3, 4, 5, 6, 7. 7 arguments. First argument is here. Second argument is here. Third argument is here. Fourth argument, 5 argument. Okay, this is it. I think. Yes, this is it. Yes. So we have first argument, and just change type this argument to p device. So e direct p device 9. And this is it. We have now structured virtual table. Our result function, which takes device, second argument, sampler state type, which is third argument, and fourth argument is keyword. Okay, and we have here the table, okay. Next, we have to find. Okay, we have release. So this is the table. We can name the table and reset present. We find it. And also this is hack function. So we have if it aren't hooked, it's using hook function to hook it logically. Okay, we have hooked function here. Yes. So this is hooked function. This is original hook function. Okay, and it okay. We'll start with reset like this. Decompile it, and okay, we have okay here. Okay, then 14, 40, 15, 6, 16, 8, okay. Then 40, 15, 6, 16, 8. So this is it. It takes 2 arguments. V2 is, I think, p device. So a1 would be device evar set evar type to e direct 3D device and we have the table. So table the table um, and second argument is e5. e5 is a2. a2, I know this is parameters, so this would be add direct 3D parameters or present parameters. So change its type to the direct 3D present parameters that type, and we have it. Bug buffer with. Yes, we have. So this is it. Params. Okay, we can now change this name to original reset. In IDA we have original reset here. To see signature opcodes, we can change in options one thing, options general and number of opcodes bytes, type 16, okay, and we have signature. Click here, use plugin SigMaker or just make signature by yourself. I want to use the plugin because it's simple and faster to create, and we have this relevant address. Open Notepad, just save it, and this is this is our original reset function, but this is relevant address, so we have to add some opcodes to get address of original reset. And when we just plugin test this pattern, we have this address, but this address is here. So this move 0 to EBP and variable 4, but we have to be here in this address. We have here, we have to be here. So we have to, I know I'm using very much. We have to add some bytes to get this address. So we're starting from here. 1, 2, 3, 4, 5, 6, 7 bytes. When we add 7 bytes, we are here. So this is good address. But what we can see here, this aren't only original reset address, but it also is call. So this is call original reset address. But we want only original reset address. So we want to add 2 more bytes. We have 7, 8, 9. And when we add 9 bytes, we are here. So we have original reset address. So yes, we have to add 9 bytes to get good address. And second thing what we have to find is present address. We have here hooked present function address. We go to this function, decompile it. We can close this function. It didn't require it. Okay, when we open this function, we want to find original present function. What we see here, we have here original present function. So 10, 40, 15, 6, 16, C. 10, 14, 40, 15, 6, 16, C. So this is it. We have V5, V5 is A1, A1 is our P device. So this is the direct P device pointer. I think I just typed something wrong. Indirect PD device 9. Okay, we have here the table, and argument 2 would be source, it should be destination, handle window, and RGN data. So dirty region, I think. So this is it. We can name it original present. When we go here, we have original present, but we want second original present. This is better signature, so I put this second. Edit plugins, SIGMaker, create signature, copy, and just test it. Okay, we are in a good address, but we have the same problem like before. We are all this address, full this address. You know, all these opcodes. So we want only this without all function. So we adding 2 bytes 1, 2, and we have address. Okay, copy this, paste it here, add 2, original reason address. This is it. So we have patterns to version 32 bits. Now we want to find signatures to 64 bits. So okay, text view plugins function string. We have strings, open view strings. Okay, find failed hooking. Have failed hooking with this function, decompile it. Yes. 16 bits loops functions in 64 bits. It can look different, but it work the same way. Example, I don't know. There are the same, but no. In 32 bits we have ECX, but in 64 bits we have RCX. So yeah, of RBX to RCX. In 32 bits will be EBX to ECX. So yeah, this is different. So yeah, go to our decompiled function. We have a log function to print log. Okay, virtual protect. So this is our hook function. Change name hook function. We can use the same method like before. Let's copy this here. Find this function. Decompile it. This is it. B11 A7. This should be pointer. I think pointer. Yes, pointer, but I don't know if the device. Uh, so yeah, this is it. So this we have here all our functions. Yes. Set type indirect device name. Okay, we have it. So this is present, this is reset, functional, this is the table. Table, table. Okay, let's start with reset. Reset. Others. Decompile this. I think this is it. 18, 81, 19, 2. Zero. Yes, this is it. This is our P device. Our just the table. I want to copy here. I don't want to make mistake. Okay, this is wrong. Table. Maybe this is good. Yes, this is good. The table here will be direct 3D present parameters. Pointer or uh, pointer, I think. Okay. So yes, this is it. Original reset. Original reset. Oh, of course. Yes, this is it. Make and we are here. 1, 2, 3, 4, 5, 5 bytes. Original reset. Now reset reason. 8119 to ED8. This is it. A1. Direct 3D device 9. Next is source destination. I don't remember this. This is correct. Or toggle rack. Engine. Okay, this is good. E device rack source. E device. Watch. Source. This is window. And this is duty ready. Duty ready. This is original present. Okay, we have it. Original present. for a second. Plugin. Okay. Ugly. Bye. Original prison. And now I want to find P device in shader API directives 9 at DLL. This is 32-bit program. Okay, open shader API directives, default settings. No, I don't have change view to text view. Plugins and plugins function string. Open view things. And I know I reversed it very multiple times, and I know in a function where we can get p device, there are string what look like this: c vertex and c vertex buffer directx8 allocate. Go to this function. I know after getting p device we have tests to our p device. If it's correct, go to here, go to that, go to here. Yes. But it isn't, just don't do it, just don't do this section. Okay, this is there are tests. I know P device is located in ECX. ECX. We have here all the word pointer ECX plus 16.8 offset. 16.8 offset is offset to create vertex. So yeah, we have to get P device before we adding 16.8 offset, because we want just simple P device, no C vertex function. So okay, ECX. Here we see move from EX to ECX. So EX is first address, or address which one have P device before. So EX, move EX. We see there D word. D word is a pointer, static address. We see here static address, and this is P device. Yes, this is P device. This is simple to get P device in shader API DirectX. So yeah, thanks for watching and see you soon. Bye guys.